Hello there, MCT4C fans. Day 32. Um, Lesson is the first day, big day actually. Today's a huge day because we get to learn how to use a new button on our calculator. So that's wicked awesome. Um, we're a little bit from that right now. Um, we're starting with this idea of recognize logarithms. There's the new word, and that's going to be the new button. It's all very exciting. As the inverse operation of an exponential function. This idea of inverse operation is how we get going thinking about logarithms, and it's a bit of a slippery topic, and our textbook does a terrible job explaining it. So, be patient with this lesson, this note, with if it goes a little slow for you. State the opposite operation. This idea of the opposite operation, you've known about opposite operations since you were little, right? This idea of certain operations in math are pairs, adding and subtracting, multiplying and dividing are pairs, and so on. Those are actually inverse functions. And if you took MCR3U, you've talked about this quite a bit. MCF3M, if you took that one, not as much, and so that's why I'm kind of doing um, this initial talk for those folks. The MCR people who took MCR3U, this might be old news, okay? So bear with me. The operation, adding 7, well, what's the opposite operation? It's subtracting 7, right? No problem. Multiplying by 6, well, it's divide by 6. Opposite operation. So if I had a function, this is, take the input and subtract 3, well, what's the opposite operation? It's going to be add 3. The notation would be x plus 3. How we show inverse functions, so if f is a function, the inverse is this little minus 1, okay? F at minus 1. So if you see that, it's not in our textbook, but that's what we should mean by opposite operation, inverse operation, minus 3 and plus 3. So square root, well, what's the opposite of square root? It's squaring. And in fact, early on, I think this was when we did the trig functions, we talked about functions, right? Functions were sort of this rule where we took an input and did a rule to it, and we ended up with an output. This is and only one. It couldn't be two different things. This is what the idea of a function was. This was the domain, this was the range, and so on, right? And there was this mapping thing. Well, we could think of the inverse function is the one that undoes this. All right, it's the rule that undoes this. So inputs become outputs and outputs become inputs. It's the undoing function. So if I want to square root something and I want to undo that, well, I would square it, right? Even something like sine, I know what the inverse function is because, well, because I've solved some equations using the inverse operation of sine. Let me before I write that in here, let me just go to this page. So we've solved some of these equations. We think of doing the opposite inverse operation to solve these equations. The opposite operation is adding here, right? And here, what's the opposite operation? Well, it's square root. Opposite of square is square root. The opposite operation of signing something is the inverse sign, right? We talked about this. So way back in grade 10, we were talking about inverse functions, and there's that little minus 1 notation that shows an inverse function. It's the opposite operation of taking the sine of something is taking the inverse sine, or we often call it second function sine because that's how we do it on a calculator, but this is the inverse sine. Right? And so back on here, we could say, what's the opposite operation of that? It's the inverse sine of x. And we think of doing the inverse operation. What's weird here, what's the inverse operation of an exponential function? Now, if we look at this one, we'd like to know some sort of operation that gets it to be x equals answer, whatever the answer used to be. Right here, it was great. We had the inverse operation of sine, and it was great. It was a button on a calculator, and we could do it. How we've been solving these questions is by writing, you know, both sides, and I'm not going to go through and solve this one, but this is the sort of thing we were doing, right? Or we use guess and check, or we use graphing technology. But wouldn't it be nice if we knew what the opposite operation, the inverse operation of exponential function base 6 would be? You know, what button could I press on my calculator to get an answer? This is great. This still frustrating, and until today, okay? Um, right now we don't know. But I want to show something before we get into our note. I'm showing lots of stuff, I realize. Is I want to show this relationship between a function and its inverse on a calculator. So, for instance, we know one function might be x minus 3, and then its inverse function, its opposite operation, would be x plus 3. And I'm going to show this on the graph. There's x minus 3, there's x plus 3. Okay, well, they're two lines, fine and dandy, but watch this. What about if I had 6 times x and 6 divided by, or sorry, x divided by 6, multiply by 6 and divide by 6. Those are opposite operations, right? Divide by 6. There's 6x, there's x divided by 6. Looks like something's going on here. I think another one here, maybe I want to try this x squared and square root of x. Now this one's kind of weird because I can't take the square roots and negatives, but let's have a look. There's the parabola, and there's the square root function. It looks like they're reflections of each other, and that's it exactly. A function and its inverse are reflections of each other, and I'm not sure how this is going to work out, but let's see if I can do the sine one. Right? If I have the sine of x, and this might give me an error, I don't know. Oh, this is going to be fun. What's this going to look like? Oh, this isn't very fun at all. But again, it looks like it might be a reflection of each other. I'm going to change this to, the calculator likes being in this mode for graphing these things. So let me do this again. There's the sine function we recognize. And what about the inverse? Well, if I zoom in here, what does it look like? Does that look like a reflection, at least for the little chunk that it did graph? Sure it does. Sure it does. I don't know why didn't it graph the rest. It should be going back and forth on that axis, but it's a reflection. That's pretty cool. So what does that mean? It means even though we don't know what this operation is, what this inverse operation is, we know what the graph looks like because we know what this graph looks like, right? And this gets us to our note. So the lesson is 4.5, and we're talking about graphically the inverse function is a reflection. And a reflection actually in a line. And we'll show that in a bit, but it makes sense. If I get back to my x minus 3 and x plus 3, and then if I were to graph the line y equals x, I'm going to go zoom square here. There's plus 3, there's minus 3, and it's a reflection over that line. That's pretty cool. And if I tried some other ones, some other functions, I have maybe the square root of x and x squared, it'll be easy to see that that line is the reflection line, y equals x. There's 1, y equals x, and there's the reflection. Pretty cool. And so that means if we're wanting to find the inverse function of the exponential function, well, let's graph that function first. Remember, we know how to graph this. We've done only about 150 of these. There's y equals 2 to the exponent x. And I'm actually going to write these points on here for a reason you'll see soon. And this is -1.5. And so if I think of the line, reflection line is y equals x, means it's going right up the middle. X and y coordinates are equal to 2. There's 3, 3, and so on, 4, 4. This is the line y equals x. It's a reflection on over this line for this magic inverse function. So here becomes here, here, and notice 0, 1 becomes 1, 0. 1, 2 becomes 2, 1. It's over here somewhere. I can't quite see that, but I know, well, so far these coordinates have just switched spots, so it's 4, 2 right there. And does that look like the reflection? You betcha it does. And I can see, and what about down here? This point, -1 becomes a half, -1 down there, a half, -1. And this graph is the inverse of y equals 2 to the exponent x. This is called a logarithm. There's that word, logarithm, base x. Or base 2, rather, not base x. Base is 2. And notice, this kind of makes sense, this switching of coordinates kind of makes sense with what I was talking about earlier, right? Where this was x, this became y, but now those switch places. The inputs for the inverse functions becomes the y's, and they switch places. X and y become inputs, becomes outputs, outputs become inputs. The inverse function just is a big switcheroo. And so this kind of makes sense. We're going to continue this logarithm business in the second video, okay?